Have you ever wondered how enzymes and transport proteins work? No? Well, don't you worry, I'm here to tell you anyways. So, for starters, enzymes. Enzymes are these little things that are usually protein, but also could not be protein, but it could be protein, but it's mostly protein, but it's not really always protein, that helps speed up chemical reactions in the human body, or like literally any living thing body. And they have this like active site thingy majiggy that binds to a substrate, and it either breaks the substrate down or it puts it back together. And the finished product is called, well, a product. And they're made of long chains of amino acids that are held together by peptide bonds. And they they speed up the reaction by lowering the activation energy needed for the reaction to start. And if you compare the activation energy with or without the enzyme, they generally lower the activation energy by reducing the energy needed for reactions to come together and react, basically. And that is about it. And next up, we have transport proteins. Transport proteins are like, well, they transport and are proteins, basically. And there's two types of transport protein. There is the active transport protein and the passive transport protein. And for the first bit, we're going to first talk about passive transport proteins. They are basically when substances traveling through the normal cell membranes are way too slow, and then they jump in and kind of speed up the process. That's really, really vague. So, how does this work exactly? Well, passive transfer occurs by simple diffusion, or by pores in the plasma membrane. The passive forms of transport, diffusion, and osmosis move material of small molecular weight. They're natural, so they're really just a tunnel. There's just no force applied, so naturally they don't need any energy because there's no force applied once again. And it flows from high concentration to low concentration. It can't go the other way because there is no energy once again. So it can really just go from high concentration to low concentration. And then we have the active transport proteins, which is quite literally the opposite of passive transport proteins because they're active. They go from low to high, or sometimes they force stuff out of the cell membrane. These do need energy because it's being forced, it's not natural, it's going from low to high, it doesn't make any sense, so you need energy for that. And the energy is called adenosine triphosphate, or ATP for short. And a little bonus, lock and key module. It's basically a model slash theory that was produced by Emil Fischer in 1894. It was proposed to say that enzymes and their specific substrates are, well, very specific. And one type of enzyme could only be used for one type of substrate. Because the active site of the enzyme fits with a specific substrate, just like a key fits in a specific lock, it's hence named the lock and key module. However, it fails to explain how the transitional state of the substrate works and exists, and thus a new model was proposed to explain the state, known as the Induced Fit Model. And if you want to know more about this model kind of thingy majiggy, you can scan the QR code on the screen. I'm not going to cover it. That is about it. Thank you so much for watching this video, and if you want, you could go through the PowerPoint again and, well, read stuff if that's your thing, but hope you enjoyed. Have a good day. Bye.